This is Whiskey 5 Mike Alpha Echo, Travis County, Aries, Austin, Texas, y'all. In this video, we'll be installing a solder male PL-259 type connector onto an LMR-400 Ultraflex clone cable from DX Engineering. The PL-259 connector comes in two parts. A body and a barrel, and two styles, silver plated and nickel plated. You'll want the silver plated version. Solder doesn't stick very well to nickel plating, and the silver plated version is dull in color, whereas the nickel plated version is very shiny. We'll start our prep by making sure that we have a clean square cut on the end of our coax using our coax cutters, and then we'll use the PL-259 body as a reference in order to locate our first cut. In this assembly process, I'm going to be using a razor blade. I've installed about 100 connectors using a razor blade and not cut myself yet. However, if you choose this option, you may want to make sure you have good quality healthcare insurance. We'll want the tip of the center conductor to come to the tip of the connector body, and so we'll want to make our first cut approximately right here. In this cut, we'll be cutting through the jacket material and the shield braid and down into the center dielectric. We don't want to cut all the way to the center conductor and nick it, because RF propagates along the skin of the connector or the conductor, and nicks in that center conductor will degrade the performance of the resulting connector. I'm going to make a shallow cut to begin with in the jacket material, and then I'm going to cut progressively deeper through the shield and down into the dielectric below by feel. And then we'll remove the components of the coax. First is the outer jacket. This is polyvinyl chloride, PVC type material. And next comes the shield braid, which in LMR 400 type coaxes is a very nice tightly woven shield material. And the coax also has a second foil shield around the center dielectric. We'll remove the foil shield in the center dielectric by inserting our thumb into the cut that we made and giving it a strong clockwise twist with respect to the cut end of the connector to break that dielectric free, and continuing to give it a clockwise twist, we'll pull that dielectric off of the center conductor. The dielectric in this type of coax is foamed polyethylene, which has a relatively low melting temperature. During the prep process, we'll also want to make sure that the strands of this stranded center conductor remain tightly woven. If any of these strands break free of the center conductor, then we won't be able to subsequently insert it into the PL-259 body. The next step in the prep is to locate a second cut, again referencing the connector. We'll be exposing the shield braid for this cut, and we'll start the cut approximately right here. And this cut will be just through the jacket material, and I'm not even going to cut all the way through the jacket material. I'm just going to make a scoring cut, and then I will make a transverse cut a little bit deeper toward the end and then use my fingernail to peel back the jacket. The next step in the prep process is to use your small diagonal cutters or braid trimmers to trim back the end of the braid from the dielectric. This will help avoid a common fault that occurs in when these connectors are being assembled, where the shield braid comes unraveled during the assembly process and some of the conductors get into the dielectric area and create a short. We'll want to examine that dielectric area carefully to make sure that there's no conductive material left in that area. The next step is optional. However, it's probably a good idea if you're going to run any power into the connector, and that is to tack the braid down with solder. So we will, because this is the first time we've been using the soldering iron, we will apply a little bit of solder to the tip. This will help clean the tip and prepare it for soldering. And then clean the tip with our floss or wetted sponge. Oxides develop on the tip of a hot soldering iron, and if they get into the joint, they will prevent the solder from sticking. So we will begin this process by just laying the solder across the coax shield and quickly tapping it with the soldering iron to apply a small amount of solder. And we'll go around the shield braid. We want to apply very little solder in this process. Otherwise we won't be able to insert the connector body. And also we want to apply very little heat in this process because we don't want to melt the center dielectric. And if we get a lump of it, we can just swipe that back quickly. Again, this step is optional. The next step in the process is to add a piece of 1/2 inch double wall heat shrink tubing, and then the connector body with the threads facing the cut end of the coax. And then we'll thread the connector body onto the coax. We'll want again a nice tight weave on this stranded conductor, and we will have to thread the center conductor into the small hole in the body by feel. We don't want to apply any pressure in this process because another common fault in the connector assemblies is that one of the wires in the center conductor strand will peel away from that strand as you're inserting the connector body and cause a short. This area of the connector body is threaded and bites into the coax jacket, giving the coax a great deal of structural strength. This process of threading the body onto the coax can be awkward, particularly with some coaxes, and this tool is available from DX Engineering that simplifies this process. It screws onto the connector body and gives you the leverage and control necessary to screw that connector body onto the coax. And we'll screw that on until the center conductor of the coax emerges from the hole. If we look in the holes, we'll see braid material in the holes, and then we're ready to solder. If the center conductor extends beyond the notch in the end of the connector, we will just cut that off with our braid trimmers at this point. And before we begin soldering is a good time to continuity test the connector to make sure that we haven't introduced any shorts in the assembly process. At this point we'll use a vise. This is a three-handed operation, and humans only have two hands to work with. So a vise is an essential piece of equipment when doing this. We'll straighten out a nice piece of solder. By straightening it out, it allows you to better control the solder when you're applying it to make sure that it's applied to the correct location. We'll clean the soldering iron tip and apply the tip into the notch with the center conductor. We want to apply a minimum amount of heat for a minimum amount of time in order to make this solder joint and avoid melting the Teflon or other insulating material holding the pin into this connector. So we'll hold heat here for about 8 seconds or so, and then feed solder onto the center conductor exposed through the notch. And when everything's hot enough, the solder will wick into the center conductor. If you happen to get any solder on the center conductor at this point, that's no big deal. You can take your super wick and placing it between the unwanted solder and your soldering iron, just swipe the super wick across the area to remove any unwanted solder. The next step is to fill the holes in the connector body with solder. Some folks have speculated that this doesn't need to be done, but I certainly disagree with that. Filling the holes with solder assures good electrical conductivity between the shield braid and the body, and it makes the connector more weather resistant, and also it adds some additional structural stability to the connector. By trapping the shield braid in the solder, it prevents the coax from twisting in the connector body, and which will eventually cause a break in the conductors of the coax. We'll start by holding this soldering iron across the hole. Again, not down into the hole. Our objective here is to heat the connector body, not the coax underneath. We'll hold it here for about 10 seconds or so to warm up the area. And then we'll feed a sufficient quantity of solder into the hole to fill the hole. and give it a little swipe at the end with a soldering iron. You don't want to put too much solder in this hole or too little, and you certainly don't want the solder to run along the outside of the body to get near one of the unsoldered holes. If it does, then you won't be able to solder the unsoldered hole, because the solder will want to glom onto the solder that's already there, and you'll probably have to start over if that happens. We'll solder the opposite side. In this case, I'm going to apply my soldering iron across the hole in this fashion. This is a 1/4 inch chisel tip, so it does not fall into the hole, and heat the coax below. We'll hold it here for about 10 seconds or so. Straighten out the length of the solder. And then we'll apply the solder into the hole in sufficient quantity to fill the hole. And give a little swipe of our soldering iron to make sure that the hole is completely filled. And then we'll do the remaining 2 holes. This is arguably the hardest part of installing a connector, and requires some patience and practice. Don't get discouraged if it takes several attempts to solder all 4 holes of the connector. Even folks who have soldered a lot of these connectors frequently have to start over. This is a good time to continuity test your connector to make sure that you've not added any shorts to the connector. And on this particular one, I think I'm going to apply just a bit more solder to the center conductor. And we'll continuity test again. We can slide the barrel and screw it back on the connector body, and slide the heat shrink tubing up. You'll need to leave a gap between the barrel and the end of the body so that the connector barrel can work, and then use a heat gun to shrink the tubing. And that is a solder PL-259 male onto an LMR-400 Ultraflex type connector. And don't get discouraged if it takes several attempts. I think it was about 4 or 5 attempts before I had my first good, well-built connector.